Welcome back, Professor Rimbold. Today, in advanced cinematography, I have a multi-mass static system to analyze here. Now, it may be hard to see without looking at my PDF, but we've got two masses here, A and B, connected by a wire and hung by two angled wires. This wire, T3, is at angle theta. B, I've gone ahead and skipped the calculations and just assigned it 50 newtons due to gravity. A has 40 newtons. This is tension 2, or T2. T1 is at an angle of 35 degrees. Here are our free body diagrams. For A, we have force due to gravity, FT2, FT1 at 35 degrees. B, we have 50 newtons gravity, FT2, and FT3 at theta. So, solving for tension forces T1, T2, T3, and theta. Since we are static, we know that F net is going to be 0. So the x components on box A are going to be equal to negative T1 times sine 35 degrees plus T2 equals 0 newtons, total F net. The y components are going to be plus T1 cosine 35 minus 40 newtons of gravity equals 0 newtons. X components of box B also equals 0. Negative T2 plus T3 sine theta equals 0. Remember, we don't know that angle yet. Y components are similar. T3 cosine theta minus 50 newtons equals 0. So we now have the equations that we need to come out with our answers. We will have to rearrange them a little bit. But so in order to get T1, we can set T1 40 newtons over cosine 35. Very simple, comes out with 48.8 newtons is our force on T1. T2, we can arrange as T1 sine 35 equals 48.8 newtons times sine 35, comes out with 28 newtons. There we go, that's T2. Now that we have those, we can rearrange a couple of these equations. If we use the y components over here, we can set T3 sine theta equals T2, which is 28 newtons we already established, and minus T3 cosine theta equals 50 newtons. Now, now that we've rearranged these, if we divide these two and these two, then we come out to tangent theta equals 28 divided by 50 newtons. That comes out to 0.56. So if we bring this tangent in here, we can solve for theta. Theta equals tan negative 1, 0.56, which comes out to 29.3 degrees. That's our theta. Now let's look for T3, the force on T3. This one is simple enough. Now that we know the cosine, we can use our equation from over here and just plug it straight in. 50 newtons divided by cosine of 29.3 degrees comes out to 57.3 newtons on T3. Here's a little breakdown of our answers. The force on T1 is 48.8, the force on T2 is 28, the force on T3 is 57.3, and our theta came out to be 29.3 degrees. Thanks. Sorry for my shaky hand. Had a lot of caffeine today.